Dear students, now I want to discuss one JEE advanced question 2024. So consider the following volume temperature diagram for the expansion of 5 moles of an ideal monoatomic gas. So graph here, volume temperature graph given. Considering only PV work is involved, the total change in enthalpy for the transformation of state in the sequence x2y, x2y, y2z is. So here molar heat capacity also given and molar gas constant also given. This is the question. So this is from thermodynamics. Okay. So volume temperature graph given. So we can consider only PV work is involved and total change in enthalpy we need to calculate. Total change in enthalpy we need to calculate in joules. So what is the graph here? X2y, y2z. We have to calculate for this total change in enthalpy. Now here x2y, this is at constant temperature. So x2y, that is isothermal process for an ideal gas. So temperature is constant now here, that's why delta H value 0. So now here change in enthalpy, total change in enthalpy, total change in enthalpy, delta H is equal to delta H, we can write for x2y plus delta H change in enthalpy for y to z, y to z. So sum of these enthalpy values we need to calculate. So now delta H x2y, 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 y to z, okay, x2y. So here temperature is constant, x2y temperature is constant, so it is isothermal process. So temperature is constant. Okay, temperature is constant for x2y, so that delta H value 0, x2y 0. Understood? Now we need to calculate delta H change in enthalpy y to z, y to z. So temperature constant, that's why change in enthalpy 0. Now we need to calculate y to z. So y to z, that is isochoric process. Why? Here volume is constant. Once observe which is constant here, volume is constant. So it is isochoric process. For this one temperature constant, isothermal process, delta H 0. Here isochoric process. So which is constant here? Volume is constant. So volume is constant. So it is isochoric process. Which one? Isochoric process. Understood? It is isochoric process. Now here actually work done 0. Then first we can calculate delta U. Delta U y to z process. Delta U. Delta U equal to, what is the formula? Mole number into here molar heat capacity at constant volume into delta T. This is formula. Then N into molar heat capacity at constant volume, and we can write here temperature change T2 minus T1. So now how many moles gas given here? Here 5 mole ideal gas. 5 mole ideal gas. We can write here 5 mole into CV value how much given? So 5 mole into CV value how much given? 12 joule mole inverse Kelvin inverse into temperature how much given here? Difference 415 minus 335 Kelvin. So now here we can cancel mole into mole inverse, Kelvin into Kelvin inverse. Then we will get in joules. What is that value? 4800 joule. So this is the delta U value. Now we need to calculate delta H value. What is the formula? Delta H by 2Z is equal to delta U plus delta PV. Now delta U by 2Z, and here we can write nRT. Now delta U plus, here we can write N or delta T. Understood? Now we can calculate here delta U value 4800 joule plus, and N again 5 mole gas, and molar gas constant 8.3 joule mole inverse Kelvin inverse into temperature difference. Again we can write 415 minus 335 Kelvin. Understood? Now here mole into mole inverse cancel, Kelvin inverse into Kelvin cancel, we will get in joule. Then 4800 joule, if we simplify these values, we will get what is that value? 8.3. So we will get here, so 415 minus 335, that is 80 into 8.3 into 5. What is the value? 3320 joule. Then total value how much? 4800 plus 3320. What is the total value? 8120 joule. So this is the right answer. So now this is delta H y to Z actually. Now tell me total value here. Enthalpy change total is equal to delta H x2y plus delta H y to Z. Then this value 0, this value 8120. Then total value 8120 joule. So this is the answer. I hope everyone understood this solution. So this is the process for this question. Clear? So in xy, for xy curve we got 0, for y to z we got how much value? 4 here 8120. Then sum of these values we will get, we are getting 8120 joule. So this is the total change in enthalpy for this pressure volume work. So I hope everyone understood this solution. Clear? Okay, thank you so much.